So you're thinking about changing your central air. What they're going to tell you, the questions you're going to ask, and my final thoughts. Hit the music. Hello and welcome to the Adding Energy Podcast, a podcast about energy usage, energy efficiency, and energy issues. I'm your host, Mick Lane, but you can call me Sir. This is meant to be everything I would tell a friend about changing their central air system, because I have a friend and they're changing their central air system. So the first thing I would say is that always remember the repair is going to be the cheapest. For me, on a central air system, a repair is going to be like $300 in parts and $300 in labor. Maybe something like $500. Once you get beyond that, I start thinking about replacing entire chunks of a system. So if you are going to replace a chunk of a system, let's start with the pieces. So the pieces are the condenser. That's the part that's outside. That's the part that makes all the noise. Sometimes it's called the compressor because the compressor is in there. It makes the most noise, uses the most energy. The next part is the evaporator, sometimes called the case coil or the egg coil. That is the part that sits inside. It gets cold. That's where all the condensation comes off as it takes the humidity out of the air. It's drained. It has the refrigerant lines going to it. The final piece would be either the furnace or the air handler. I would call it a furnace because usually they have natural gas or another fuel going to them. They blow the air around the inside of your house. If your house or if your system is 10 years old or younger, I would replace a piece. Now, what am I talking about when I say a piece? A piece might be an evaporator if something's gone weird or wacky or wild and it's cracked and they can't fix the coil or they can't replace the TXV or whatever the problem is, and they're going to need to give you a whole new one. If the system's 10 years old or less, go ahead and replace that whole part. Furnace, air handler, if that's broken and can't be repaired, throw it away, get a new one. Condenser, if that's broken, throw it away, get a new one. If it's older than 10 years old, that's when I start thinking about replacing the whole thing. What's the whole thing? Well, I mean everything. The evaporator, the line set, the condenser, the air handler, furnace, potentially even the venting or breaching, depending on what needs to happen there. No, don't change the ductwork. You don't necessarily need a different filter or new registers, but you are going to be touching enough of the system where you want it to kind of all match. Now, when I say match, what do I mean? The evaporator and the condenser both need to be sized for the proper refrigerant flow. So it doesn't mean that there has to be an exact one going back and forth, but there are only a handful of condensers and evaporators from a single manufacturer that work together. Then the evaporator and the air handler and furnace, they need to be able and sized for the same airflow. So there's a handful of units that can go back and forth between those. So if you replace the air handler, the evaporator, and the condenser at the same time, most likely they're going to work well together. They're going to have the least number of issues and conflicts. If you start replacing individual pieces or parts or this or that, it's not impossible, and it's not that it can't be done, but about every 5 to 10 years, we change something significantly. First, it was TXVs, and then, it used to be accumulators, and it used to be different changes in things like refrigerants and, variable speed compressors and single speed compressors and on and offs and starting capacitors and all that stuff. As all those things change, how long the fan runs after the compressor turns off has changed. How long the furnace runs, how long the fan runs before the furnace turns on, how long the fan runs after the furnace turns off. Those delays and those settings, if it's looking for something and it's not there, they have to add another $50, $100 box. They need to change a little this. They need to change a little that. And no one goes through and sits there and looks at what the ideal timing is for run fans or this or that, because they kind of work fine without it. But if you're going to get most of this stuff, you might as well do it all at the same time. Now, you're not going to save some kind of ridiculous amount of money like you would if you were doing a major engine repair and they say, well, for basically just the cost of the parts, we can put in new spark plugs and wires and thermostats. It's not going to save you a ridiculous amount to replace the furnace with the air conditioning system. It's going to cost about the same amount it costs to install a furnace. But If you replace the whole thing at one time, that gives it you start clean, right? You don't have to worry about, well, I know I replaced this, how long is the whole thing going to last? Yeah, if you replace your condenser because a tree limb falls on it when it's 8 years old, there's no reason to think that whole system won't go for the standard life of, say, 10, 15, 20 years. 10 years more being 15 or 20 years of total length. That's what residential equipment is supposed to be for airside stuff. So that feels about right. Once you get into like 13 years, yeah, you probably don't want to replace just the condenser. Maybe you do, maybe you don't. Obviously, living situations and systems, and there's all a bunch of situational stuff. These are general overhead guidelines. If you need a new transmission in a 10-year-old car, I'd probably have similar numbers and similar thoughts. So, the things that they might bring up to you. The first one is the electrical service for the condenser. It is the biggest power-using part of the system. And here's the strange news. The old systems, specifically if you have like a 20-year-old system, something around 2000, those systems tended to have lower circuit ampacity requirements. So you probably have something like a 20 amp breaker or a 30 amp breaker for those systems. And that's fine for those systems, but they probably had a minimum circuit rating of something like 17 amps. The new ones are going to use less power overall when they're running, but they're going to need that circuit breaker sized for like 23 amps. So you're probably going to end up getting charged to change out the breaker, the wire from the breaker to the condenser, and the little local disconnect thing that's on the wall there so they can shut it off so that they don't get zapped while working on the unit. Types of numbers on that. If you're dealing with relatively modern construction and a good panel and things like that, and there's more than enough power in the system, $500. If it's old or a really long run, maybe you're gonna have to get up to 40 amps or something for a 6-ton condenser or something like that. Maybe you're talking 1,000, somewhere in there. You can probably save a little bit versus what your HVAC guy's quoting you if you had an electrician came in and did it all for him, because most likely that guy's going to take whatever the electrician is charging him and add $100 or $200. So it'd be for the phone calls he's got to make and making sure the guy's there and on time and gets all his stuff done. A local municipality thing. If your panel is old, now it probably means ancient. If your panel is from like 2000, there shouldn't be a problem. But if it's like from 1950s and has fuses or something like that, or if it was the low rung stuff in the 1970s, they might require you to replace the entire thing if you're replacing a breaker in it or a major electrical load attached to it. So basically, if your contractor is going to pull a permit, which he should, to do an HVAC replacement if it's required by your municipality, and he's got to change out the circuit breaker, there's a chance you'll have to replace your whole panel. How much does that cost? Lower end, something like $500. The panel frame and shell and parts. Shell's like 160. The face cover's like 60 to 80. The breakers in it are a couple bucks a pop, $10 or so. So when you put that all together, you end up maybe $500 if it's an easy installation, $1,000 if it's complicated or bigger or whatever's going on. So those are the two things that if the contractor tells you that, he's probably not just selling you a line. Now, my thoughts for energy efficiency. Adding energy is like adding energy efficiency projects to the stuff you're kind of doing in your everyday life. So by that I mean, if you happen to be doing this air conditioning system replacement, let's add some energy efficiency. So the first one you're going to love, because if you're a cheapskate, it might make your system even cheaper. Air systems are notoriously oversized, and that tends to make them less efficient, because with air systems, a lot of their inefficiencies is they're turning on and turning off. So if you can get that system to run for longer periods of time, that's better for the efficiency and the life of the system. The only example I could give is if you were a car and you drove your car like 5 minutes and then stopped and then drove it 5 minutes and then stopped, That's not as good as hopping in it and driving for 15, 20 minutes, 30 minutes, and then stopping for, even if it's 5 or 10, and then running another 15, 20, 30 minutes. So a quick check, if you can do this, if you get your house size of conditioned square feet, that would be like what you would use if you listed it for a real estate listing to rent or to buy or sell or whatever. You take that square footage, and if you multiply it by 25 for 25 BTU square feet heating. So if you had a 1,000 square foot house, 25,000 BTUs, 50,000 BTUs would be a 2,000 square foot house. Go ahead and do the math. And then for air conditioning, residential, we go like 400 to 600. If you live south of the Mason-Dixon line, maybe you're only 400 square feet per ton. And if you're up in the north, maybe 600 square feet per ton. My current house is about 2,400 square feet, and I have a 3-ton condenser, so I'm even a little bit leaner than that. If you're in those ranges or you're way out of those ranges, I would pay a qualified or a capable person to do a heat load calc of your house. Now, they're going to try to figure out what your walls are made out of so they can get an R value in your windows and how old and how drafty and your ceiling insulation and all those types of things. And they're going to come up with a number, and that number is going to be a heck of a lot better than the 2 ways I just gave you. But it probably won't be orders of magnitude off of that. How far off are air systems? My last house, the air system was about 4 times bigger than the calculated heat load. It was basically 100,000 BTU per hour furnace for a house that needed about 25,000 BTUs per hour. This house is about 1 model size bigger than I need. So I need like 60, and I got like 80. So you could shrink your unit by a size. Now, it's also going to depend on what you need for air conditioning and all those other things. So it doesn't necessarily mean you'll be able to drop down a size or 2 or whatever. But by shrinking the size of your unit, you'll have longer run times. And generally, that makes your house more comfortable on top of helping to improve the energy efficiency. Because with air systems, you kind of end up with the hairdryer effect, right? You turn the hairdryer on, you turn it off, you turn it on, turn it off, and you get a little warm while it's on, and you're a little cool while it's off. And if it just kind of ran, maybe at a little less heat output for that whole time, you end up with a much more kind of comfortable environment. That's kind of what we're going for. So if you're going to buy the smallest, cheapest system, I would do that. Now, so that's assuming you buy a single stage or a single capacity for heating and for cooling, right? So you're going to have a single capacity or single speed condenser. You're going to have a single output furnace. You could take that opportunity and buy a single output furnace that is condensing. So you jump from the 80-82% efficient to like 90-92% efficient. They will often have to change the venting, so that being either a chimney, they'll either need a liner or they'll punch out a hole out the wall and run usually a plastic venting for those chimneys. And the exhaust that goes out is so much colder that you get a lot more of that heat goes into the space. Now the problem is it is so much colder that the moisture in that condenses, and that moisture has to go somewhere else. And because of the properties of combustion, it ends up slightly acidic. So you'll need a neutralizer, and you'll need to run that to a drain that's appropriate. And all those things cost a lot of extra money. So the unit will be probably another $1,000 to $2,000 more. And then it'll be another probably $1,000 in installation for the new venting and all the other little modifications they'll have to do. General ballpark for what you should expect for a system like that: 6,000 to 8,000 for the bargain basement furnace and the entry level air conditioning system. That's about right for your average, say, 2,000 square foot house. And then, if you needed the other electrical things, or if you wanted to do an upgrade, you do that. If you're not going to change the capacity of your unit, or you may even think you need more capacity of your unit, I would at least consider a high-low system. So for a high-low system, the furnace usually has 2 different firing rates, and the air conditioner usually has a 2-speed condenser or 2 output rates. So a common one would be something like, at low speed, it would be like 2 tons, and at high speed, it'd be like 3 tons, which is just the number of BTUs per hour, 24,000 versus 24,000 BTUs per hour versus 36,000 BTUs per hour. By having those two speeds, it can spend more time at the lower speed. And generally the way the number works is if low fire is 40 to 60% and low speed on the air conditioner is 40 to 60%, the unit will spend over 80% of its hours at low fire if it's sized correctly. And we've seen it even as high as 90% of the hours the system is on, it'll be at low speed. I have a buddy whose house is very new, very modern, and when he put in his 2-speed condenser, he had to force it to actually get it to turn on to full speed by turning off everything for basically a whole day so that his house got up to like 86, 87. And then when he turned it on, it did go all the way up to high speed for cooling. For heating, low and high, similar things, you get slightly higher efficiency. Normally these units will say they're like 83 to 85% efficient rather than the 80 to 82% efficient by being on the low, high fire. And again, with that being on low fire, you get longer run times. So it generally is on more. Yes, that might sound annoying, but generally it's a lower air rate too, so it's quieter. And it's just kind of slowly brings the space temperature up and down, so you don't notice it as much. A little less of the hairdryer effect, and just kind of more comfortable. The creme de la creme, or the Cadillac, is variable, or they'll call it like multi-speed, which means that the unit will have a range over which it can change its capacity. So usually the bottom end is like 20% of the full load. So if you bought a 100,000 BTU per hour furnace, low would be like 20, and it'd be able to jump about every, say, 5 to 10,000 BTUs, so it can match the heat output to what your house needs better. Likewise, these usually have a variable speed fan on the blower, so blowing it around the house. And they'll usually have variable speed capacity on the air conditioning too, so that you get the correct amount of cooling for out there. Now, they'll call it multi-point or multi-speed. Really, the difference between 2 points, 10 points, and infinite points is not insanely noticeable as a person sitting inside a house holding a TV remote. So if it is 5 different speeds versus 100 points, those types of things don't matter quite as much as far as those things. But if you are looking to get the utility rebate or incentive, usually you have to get up to this level to at least get the biggest check. Often you have to get to this level to get the check. These units are usually rate 95 to 97% efficient for heating. And for cooling, I know I haven't been giving you guys EERs, but for the single stage, usually you're looking at an EER, or energy efficiency rating, of 10, and a seasonal energy efficiency rating of 12, which is, slightly better. That's more what you would average over a year than at the test point. For the high-low, normally you'll see the EER of like 12 and the seasonal energy efficiency rating of like 14 or 15. And then for the creme de la creme variable speed multi-point or multi-speed system, you'll normally see those EERs around 14, and then the seasonals will go anywhere from 16 to like 21. Now, obviously, you should consider what you're currently paying for gas and electricity annually. You should go back, you should go do that sheet from the podcast, from the homework, addingenergy.com/homework. And you should figure out how much you're spending on heating and how much you're spending on cooling to see if it's worth the extra, probably $1,000 to jump up to a high-low on both sides. So a high-low furnace and a high-low air conditioning system would probably be another $2,000 on the 6 to 8 we started with. And then if you were going to go up to the variable speed on both of those, that's another bigger bite. That's probably about $5,000 total. And so now you're talking about something being like $12,000 to $14,000 for a furnace, condenser, and an evaporator getting all replaced. That $5,000, if you saved $500 a year, that would make a lot of sense. But if you're only improving the system efficiency by 10 or 15%, that would mean that $500 you'd have to be spending like $4,000 a year on heating and cooling. And most of you aren't doing that. So if you're well under that, it probably isn't worthwhile for your pocketbook to upgrade to the variable speed system. It might get you the incentive check, and maybe that $1,000 to $2,000 that you're going to get from the state or the utility or whoever, that could be cost beneficial. There's tax credits, or at least there used to be for these. You'd have to look up for your specific situation to see if you can claim these. And then if you're going to do other measures, like if you're going to put in zones, the single speed system is least tolerant of zones and requires something like a minimum flow bypass. The low-high system might be more tolerant without the bypass, and the variable speed is totally designed for that, where it'll maintain static pressure, which means the airflow will be the same whether you're feeding, will be the same to each space, whether you're feeding 1, 2, 3, 4, however many zones. To talk about zones and stuff, we'll do another podcast at some point on that. But those are my thoughts on replacing your central air system. If you'd like to have specific questions, please reach out, addingenergy@gmail, Twitter, addingenergy.com, or if you know how to find me, comment below. So for the Adding Energy podcast, I am Mr. Mick Lane. Thanks for giving a watt.